All right, this is Unit 1, Section 1.1, Sampling and Surveys. So this is going to introduce our first unit on collecting data. So before we can start analyzing it or inferring things about the population, we need to know how to collect data well. So that's where we start out AP Stats. So our goal today is to be able to identify a sampling method given a description of the study and explain why a particular sampling method is or is not appropriate for a given situation. Notice that AP here on our assignment sheet is out of order. So this is their Unit 3, but I make this our Unit 1. So this is where we're going to start out. So begin for 1.1, we're going to have some vocabulary terms here. A population, which is the entire group of individuals about which the information is wanted. A sample, this is part of the population from which information is actually collected, and this is used to make inferences about the larger population. So we use data collected here to infer about the population here. And the way that we do that is in really about 3 different ways. We can do a survey, an observational study, or an experiment. So we're going to start out looking at sample surveys. This is a study to find information about a sample in order to draw conclusions about the population it represents. So this is going to collect information from our sample, whether it's humans, whether it's rocks, whether it's animals or plants or medicines. We can survey it and be able to draw conclusions about the population that it represents. We want to make sure that our sample is random. And that means that we're going to use selection using a chance mechanism like rolling the dice, picking up cards, tossing a coin, pulling from a hat. We can use bingo balls, raffle tickets, table of random digits, and a number generator. Mainly, we focus on pulling from a hat, table of random digits, and the random number generator. Those are the 3 main ways that we'll use in AP Stats because typically they can't guarantee, and I say they as in the AP board, can't guarantee that you have a dice in your pocket, that you have a deck of playing cards with you, or that you have a penny on you. They can imagine that you're pulling from a hat. We will be provided a table of random digits, and your calculator has a random number generator that we will learn how to use this unit. So an example, it says a high school student's newspaper plans to survey local businesses about the importance of students as customers. From an alphabetical list of all local businesses, the newspaper staff chooses 150 businesses at random. Of these, 73 return the questionnaire. Identify the population and the sample. Okay, so our goal is to identify what is the population here and what is the sample. So the population here is we're looking at all local businesses. So that's our interest, our group of interest here. So local businesses. And our sample, because we didn't contact all the local businesses, we chose 150 local businesses to be part of the sample. So even though we chose 150, this is our sample. We only had 73 that returned the questionnaire. So of our 150, we have some people that chose not to participate. We need to do either more to get their information back, or we need to look at maybe we should ask even more people to get our numbers up, depending on what our goal is here. All right, so there are ways that we can sample poorly and ways that we can sample well. So this idea here is we want to be able to identify the bad sampling versus the good sampling. And so the first one that we look at is a simple random sample. This means randomly, meaning using some choice object that creates a random scenario, selecting the individuals from the entire population using chance. So if this cloud is kind of the entire population, I'm going to use a randomizer to select student ID numbers and talk to those that were selected. Everyone has an equal chance. So if this was the school, okay, and I'm trying to sample our some group of students from our school, I'm going to label every single person with an ID and then randomly choose those people. And this would be becoming my sample. This is one good way to sample. A bad way of sampling is called a convenience sample. This is choosing individuals that are just easiest to reach. And so this is where if this person's trying to do a sample survey or collect their sample, it says, I'm lazy, so I'll just ask my friends. Well, these people might have different opinions or might not share their true opinions based on what the information is that you're trying to collect. So we always want to make sure that we're not introducing a bias somehow into our sample. Another poor way of sampling is to do a voluntary response. These are individuals that choose themselves to participate. So this would be if this person is now waiting just to see who's going to walk up and talk to you. And so you might have seen people collecting that information when you go to the mall and there's somebody that says, oh, just a minute of your time, or would you fill this out? Okay, they're just waiting for you to come and fill in that information. A radio opinion might be somebody that calls in and they have asked for an opinion, and so they call in, and you never get the person on the radio that's like, well, I guess I just called in because I feel meh about it. It's always going to be an extreme or the other. And that's one of the bad things when we have a voluntary response sample, is that the people that are kind of middle of the road don't feel that they need to volunteer their response because they don't feel strongly one way or the other. The design of a statistical study shows bias if it systematically favors one way or the other, so favors certain outcomes. So these two can favor certain outcomes, which is why we say these include bias. So we don't use these when we're trying to do a reliable study. I'm not saying that people don't choose to use those. It's just not very reliable as far as data that could be replicated later. Back to the good side here, we talked about a simple random sample, and really, if we can do that, that's going to be the best way to sample. There are two other ways that are good to sample, but we want to make sure that we do it well. And so the second one that we're going to look at is called stratified. Okay, stratified random sampling means classifying the population into groups of similar characteristics and then randomly selecting individuals from each group using chance. So if this is all SMS and I'm choosing everybody here and I have 1, 2, 3, 4, 5, 6, 7 people for my sample, it's possible that randomly I get 7 freshmen or 7 seniors or 7 people that are absent all the time and I can't get a hold of them. So sometimes there is a known difference. Okay, sometimes there is a known difference in our population that we might want to address, like freshmen, sophomores, juniors, and seniors, that we might want to make sure that each one of those groups is represented. So by stratifying this, we're going to classify the population into groups called stratas of similar characteristics. So now I have a group of freshmen, group of sophomores, group of juniors, and group of seniors. And then I'm going to randomly select those individuals from each group using chance. So now instead of just picking 7 random students or 8 random students here, I'm going to randomly pick 3 freshmen. So I'm going to have 3 from this group that are randomly selected. So I still might have all those ID numbers for freshmen and pick 3 of those. And all the numbers for sophomores and pick 3 of those. Same with juniors, same with seniors. And that's how I'm going to get my sample of 12 here. That's more representative of the overall population. So while this doesn't have any bias, this is completely unbiased, it is letting it be completely random. If you can justify the known difference in your population and randomly sample from each of those differences, you can still justify this as a good and valid way of sampling. Okay, the last one that is another good way of sampling is called a cluster sample. So the cluster sample sometimes can get grouped into convenience, but there's still random that's involved here. So now we're going to take our entire population and divide it into groups called clusters, where each group mirrors the characteristics of the population. So now I've taken my big population. Okay, do you see the cloud on the outside there? So I've taken this entire population that we had originally, and what I've done is I've said, you know what? Each one of these is kind of like a mini population. So this might be, if I was talking about school, I would have to think of classes that maybe have all 4 grades represented, like an art class or PE or some of the electives where they have everybody represented from freshmen to seniors. And what I can do here is dividing them into those groups, and then what I'm going to do is randomly select groups using chance. So here I would number all the freshmen and choose 3. Here I'm going to number all the groups and randomly select one of them to be my sample. Because this is a mini population in itself, I should get just a good representation here. So now this says over here, I'll put 3 random freshmen, sophomores, juniors, and seniors into groups, and then I'll roll the dice to pick one. Okay, so a cluster would be if those, and it's almost more convenient where we want them grouped together already naturally, like in an art class, but it's that idea of now I've made 10 little mini populations inside of my population. And instead of picking, some from each group, I'm picking the entire group. So maybe I pick 2 of them, and now that makes my sample. Stratified, these groups are different. So groups are different because of the known difference. In this case, the groups are similar to each other, so that when we choose one, we're getting a representative group. 3 ways that we randomly sample well. Completely random, that's our simple random sample. Stratified and cluster. We want to make sure that we know the difference between those 3. So for an example, it says you want to conduct a survey about the attendees of a rock concert and decide to take a sample. Ticket holders are seated in groups by ticket price. The $3 sections, A through C, hold 100 people. The $2 sections, D through F, hold 200 people, and the $1 sections, G and I, hold 300 people total. The lawn sections behind that, J through L, hold 400 people total. There's a grand total of 1,000 seats, and the show we know is sold out. So all those seats are taken. So if I wanted to do a sample of convenience, voluntary, simple random, stratified, and cluster, how could I describe that? So remember that this one here and this one here have bias. They're not the best ways to do it, but you can get a quick random sample, or you can get a quick understanding of that sample, but it wouldn't be something that we could apply to a bigger population. So maybe a convenience sample, I would just survey the first 100 people who arrive at the venue. Okay, so if my goal is to collect 100 surveys here, I'm just going to say, hey, the first 100 people, you're going to be surveyed. So I'm going to just ask them. You're going to have to stand in line, but you're going to be the first 100 people to be able to let into the concert. This would have some bias because maybe those first 100 people who arrive have a different opinion than the people who arrive later. Okay, there's 1,000 people and we're surveying the first 100. They might have a different opinion based on their goal of getting in there the first and the quickest. A voluntary response, maybe I'm just going to stand at a booth and wait for 100 people to come to me. So maybe I stand at my booth and I say, hey, do you have an opinion about this group that's here? Or hey, do you want to, fill out the survey for me? Convenience sample surveys the first 100 people that arrive. They're just going to be boom, 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 boom right after a while. Volunteer response is people that are going to say, no, thank you. Nope, I'm good. And you just wait until 100 people out of your 1,000 people there that could walk by this stand or booth will come up to you. Again, both of these are not good ways to sample. The first one that is a good way to sample is called a simple random sample, and we call this an SRS. So we'll use this notation frequently. And this is where we would say, let's use a random number generator. And we're going to select 100 numbers from all 1,000 seats. And then what we're going to do is we're going to meet all 100 of those people at their seat. Okay, so that means I'm going to have 100 places that I need to go to. So I'm going to have 1, 2, 3, 4, 5, and I'm just click, 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 click. And I could be moving all over, and I should, have 100 places that I need to hit up as I go around. Oop, hopefully they're not on the stage there. But this idea that a simple random sample, I'm just going to have 1,000 seats, and I'm just going to draw randomly 100 numbers from all those seats using a random number generator. But it's completely unbiased. However, it still is possible that if I randomly select, it is possible that all my people are lawn. Because there's 400 of them. And maybe I only get like one up here and most of them are lawn. It's completely unbiased, but it might not be representative of our concert goers. So what I want to do is, because I know there's a difference in opinion from the people who spent, lots of money to see this band to the people who are back here on the lawn, I have a known difference here that I might want to consider. So what I might want to do is do a stratified random sample. And so what we're going to do is we're going to divide our 1,000 people by seats. So we're going to divide them into the 3 money group. We're going to divide them into the 2 money group, the 1 money group, and the lawn group. Okay, so from those, we're going to use a random number generator. Okay, to generate and select, and I'm going to go proportional here. So I'm going to do 40 from lawn. Okay, so I took 10% of the lawn, and then I'm going to do 30 from the single dollar group. I'm going to do 20 from the $2 sign group, and 10 from the triple money group. Okay, this will still generate my 40, 70, 90, 100 people, but it guarantees that I have some from each of these categories, that we're saying there is a known difference in each of these tickets, and we want to make sure that they're all represented. So even though every possible sample isn't created this way, okay, it's not completely random. We've introduced some bias here by saying there's a difference that we know about, but it still is a way to still randomly and representatively represent the population. The last one is our cluster sample. And so our cluster sample, we're going to use a random number generator. There's a theme there. Oop, let's do random. And we'll practice doing this. Right now we're just kind of describing how. So we're going to use a random number generator to select a ticket number from the triple money section. Okay, so the first thing I'm going to do is I'm just going to pick one of these. And where it is, I'm not sure. It could be here, anywhere in A, B, and C. And so then what I'm going to do is once I've selected that, the group, all the people in line behind the seats, all the way back to lawn. So once I've chosen randomly this spot, I'm just going to go all the way back, and now this is going to be my sample. If I had chosen over here and had my random number generator give me something here at B, my group would have been all the way back to lawn here, just kind of following seat, as many as I could back. This is, again, more convenient because now I'm not sectioning off and randomly finding everything here, and it still represents all the money levels and the lawn group. So again, all of these here, simple random sample, stratified, and cluster, are good ways of sampling. If we can't justify that everybody would see our sample and justify this breakdown or known difference in our group, go back to simple random sample. If we think that this isn't representative, go back to simple random sample. This has no bias. Nobody can argue with it. These other two take in a known difference, and this one kind of becomes an easier way of collecting that data by just going straight back. Thank you, you've been chosen for the survey. Please fill this out. All right. Our next examples are looking at maybe what is wrong with the survey and which way do you think that this is leaning as far as the bias is concerned. So in the example, it says the mayor of Springfield is interested in finding out the average age of people in the city. He obtains a list of all the landline telephones in the city and then contacts an SRS, do you see it? SRS of 300 people. He uses the data from the sample to estimate the average age of all the people in the city. What's wrong with this survey? Okay, so he's using all the landline telephones in the city. He's doing a random sample there. And then he's using that data to estimate the average age of all the people in the city. So one of the things, as far as what's wrong with it, I couldn't be part of this. Even if I lived in Springfield, if my house just upped and moved over there, I wouldn't be part of this because I don't have a landline. Not a lot of people do anymore, unless you either have young children or have been holding on to that thing. So the thing that's wrong with this is not all people in Springfield, oh boy, misspelled that guy, have a landline. So this is where there might be people that are not included, even though they should be. So if he does go through and do this survey, do you think that the mayor would over or underestimate the true mean age of people in Springfield? And so in this case, I think he would get an overestimate. And the reason I say that is because older people are more likely to have landlines. Not to mention, they're more likely to be home and to answer the phone. My grandparents, we can't convince them not to answer the phone. We're like, it's an unknown number. Just let it go to voicemail. And they're like, what? But what if it's important? No, no, no. Older people are more likely to have them and to answer the phone, which is why I think the mayor would overestimate the true mean age if he only contacted 300 people on landlines. Our second example says the administration at a school wants to know the proportion of students that did all their homework last night. They select a simple random sample of, again, okay, they're doing that well, simple random sample of 100 students and send an email to each of them asking if they did all their homework last night. Of the 40 responses, 36 said that they did all their homework last night. So 90% of students do all their homework of the previous night. What's wrong with this survey? Okay, they sent out 100 surveys and only got 40 responses back. This is an issue because not enough responses. It also could be the admin is asking the question. Okay, those are two things that could be wrong with this survey. One, our goal was to get a sample of 100, and we only had 40 people respond. And those 40 people might have been very proud that they did all their homework last night. Or maybe they didn't have any, so they just said, yep, did it all. What about the other 60 students? Did they not do their homework? Were they so busy doing it that they couldn't respond? There's lots of things that could have gone wrong with that. They need to work on getting that information from the other 60 responses. Also, when the administration asks a question, it comes with some intimidation that we're feeling like you should answer one way or the other. So if I asked, it's different than a principal asking. Even better is if a student asked. If a friend asked, did you do all your homework last night? You would respond more truthfully when it's on the same level there. And so if they followed through with this sample survey, do you think the administration will over or underestimate the true proportion of students who did all their homework last night? So again, I'm going to say this is overestimate. Because only people who did their homework are likely to respond. All right, so our goal today was to be able to identify good and bad ways to sample, to create kind of a scenario representing those, and to identify what's wrong in a survey. So our practice tonight will be over that idea. If you have any questions, give me an email. Thank you.